look at Lesson 5.2, Solving Systems of Linear Equations by Substitution. Really, that is fancy for replace a variable. So there's a couple ways we're going to do this. Now, the first way, we're going to replace y here. So what does y equal? Negative x plus 3. So we're going to replace it right here. Now, you want to be careful that you don't replace this here, because in that case, your equations are going to cancel each other out. So you always want to set an equation equal to y. If we look, one's already set equal to y, so we're really good. So our step one, equation 1 is already set equal to 1. So now what we're going to do is substitute. So I'm going to replace y right here with this. So I have 3 instead of y, negative x plus 3, there's my y, plus 5x equals negative 1. Then I'm going to go ahead and solve for x. When I distribute, I have negative 3x plus 9 plus 5x equals negative 1. When I combine my like terms, I get 2x plus 9 equals negative 1. I'm going to subtract 9 from both sides. 2x equals negative 10. Divide by 2, so x equals negative 5. Now that I know what x is, I'm going to substitute x in for one of these equations. Now I have two options, the first equation or the second equation. I'm going to use the first since it's already set equal to y. So my step 3, I'm going to substitute again. Substitute negative 5 in for x and solve for y. So I have y equals negative x plus 3, replace my variable. Y equals the opposite of negative 5 plus 3. So y equals 5 plus 3. So y equals 8. Now, what is my final answer here? My final answer is always written as an ordered pair. Negative 5, 8. Always write your answer there as an ordered pair. Now, sometimes we're not so lucky and we won't have an equation already set equal to y. So in that case, we'll have to do it. So you want to make this as easy as possible, meaning do as little work as you possibly can. I bet you never thought you'd hear that from a math teacher. So I have two options here. I can solve for y or solve for y. Now, I'm just going to go ahead and use equation 1 just because, well, I can. So step 1, I'm going to solve equation 1 for y. So I have x minus y equals negative 4. Subtract x from both sides. Negative y equals negative x minus 4. Divide by negative 1. So I have y equals x plus 4. Now I'm going to substitute again. I'm going to try and spell that correctly, though. Okay, now, because it is this equation, I want to make sure I don't substitute here, and I want to use the second equation. So I have 2x plus y, which is x plus 4, equals 4. This right here was my y value. Make it a little bit easier to see. Now I'm going to combine my like terms, so I've got 3x plus 4 equals 4. Subtract 4 from both sides. 3x equals 0. Divide by 3. Now this is where I get a lot of people that'll say, hey, No solution. Not true. 0 divided by 3 is 0. Now, my step 3 is I'm going to go ahead and substitute again. This time, I'm going to substitute 0 for x. Now, I really can use any equation I want here. It doesn't matter since I'm solving for x and I have a value there. So I'm going to go ahead and do that first one. So I have 0 minus y equals negative 4. So I have negative y equals negative 4. Divide all of that by negative 1, so I get y equals 4. Now, my solution, remember, needs to be an ordered pair. Now, how do I check my work? This has to be true for both equations. So I've got x minus y equals negative 4 and 2x plus y equals 4. So I'm going to replace my variables here. Remember, this is the x value and this is the y value. I have 0 minus 4 equals negative 4. 0 minus 4 is negative 4, so that worked. Now let's replace here. 2 times 0 plus 4 equals 4. Well, 2 times 0 is 0. So I have 0 plus 4 equals 4. I'm going to do some very challenging math here. 4 equals 4. So in that case, my solution worked. Yay! All right, let's take a look here at a story problem. So a theater earned $3,640 from a concert. An orchestra ticket costs 3 times as much as the balcony ticket. Write a system of linear equations that represents this solution or situation. What is the price for each type of ticket? Now, depending on what you use for x or y, your equation may change, but in the end, we should still get the same amount of tickets. So here we go. Number 1, we're going to define the variables. And I'm going to say that x equals the orchestra, just because that came first. There's no rhyme or reason for why I picked that. So this is an orchestra ticket. And I should say that's the cost. Y is the cost of the balcony ticket. All right, now 2, I want to write a system of equations. So that means I'm looking for 2 equations here. So let's see, an orchestra ticket, that's x, costs 3 times as much as a balcony ticket. So my balcony ticket here, 3 times that is going to give me 1 orchestra ticket. And I know that these are the number sold, and since this is the cost, I've got 148 tickets times x, which is orchestra. Be careful here. 76y. So I sold 76 tickets at y cost. And that total there, whoops, I don't want to use a dollar sign in my equation, is 3,640. Okay? So my next step is to solve. Well, since I already have this set equal to 3y, I'm going to use this one. So I'm going to replace x here with 3y. So I have 148 times 3y plus 76y equals 3,640. So let's see, 148 times 3, that's 444y, plus 76y gives me 3,640. Combine my like terms, 520y equals 3,640. I'm now going to solve for y. So y equals 7. All right, so now I've got Y. I can plug it in. So that means Y is $7. So a balcony ticket costs $7. But I still need to figure out what X is. So I have X equals 3Y. So X equals 3 times 7. So X equals 21. But that doesn't really answer my question. So I'm going to write a sentence here. So move it up a little bit, the orchestra tickets cost $21 and the balcony tickets cost $7. Nice job.